All right, in your 3.5 practice, this was just the theorems, I think, written out. In a coordinate plane, two non-vertical lines are parallel if and only if they have this should be same slopes. In a coordinate plane, two non-vertical lines are perpendicular if and only if their product of their slopes is -1. That's that idea about opposite reciprocals. Tell whether the lines are parallel, perpendicular, or neither. The slope of line 1, I'm not sure how you set it up, but I'm going to go 12 minus 3 up top, 4 minus 2 in the bottom, 9 over 2. Regardless of how you set that one up, you should finish with positive 9/2. Slope of line 2, when I set that up, 8 minus 10, 14 minus 5. I'm getting -2 over 9. These two lines are going to be perpendicular to each other. Their slopes are opposite reciprocals. So that one's perpendicular. When we go over to, you can run out and get a drink. When we go over to line 1 on number 4, -2 minus -10 is -2 plus 10. And then 4 minus -6 is 4 plus 6. So that's going to be 8 over 10. That reduces to 4/5. You guys want to reduce those fractions for your comparison. Line 2, 4 minus -6 is going to be 4 plus 6. 0 minus -8 is going to be 0 plus 8. That's going to be 10 over 8. That's 5/4. This is neither. These guys are reciprocals, but they're not opposite reciprocals, so this would not be parallel or perpendicular. And then for these ones on the bottom, this is the stuff that hopefully you guys can knock this out, getting better with it. With the first two problems here, we've got parallel lines. So that means that this slope is going to be 4, same slope as what's here. And so then to solve, I'm going to say, all right, right now I have y equals 4x plus b. I don't know b, and I have an x and y I can use. So 3 is my y value, equals 4 times -1 plus b. 3 equals -4 plus b. When I add 4 to both sides, I get b is 7. So for this equation, parallel to it is 4x plus 7. That's just kind of a fluke that it was opposite of this other one. That's not always the case. In number 6, we've got to deal with this point and the slope of -6, so it's parallel. So right now we have y equals -6x plus the b we need to find. When I use my x and y, -3 equals -6 times 2 plus b. -3 equals -12 plus b. When I add 12 to both sides, add 12, b is 9. So then this equation is y equals -6x plus 9. Now we go to perpendiculars for 7 and 8. Perpendicular slopes are going to be opposite reciprocals. So for this one, if the slope is -3, the opposite reciprocal is going to be 1/3. So my equation is going to be 1/3 x plus some b I have to find. I'm going to use my point. 10 is equal to 1/3 of 6 plus b. 1/3 of 6 is 2. When I take 2 away from both sides, I get b is 8. Y equals 1/3 x plus 8 for this one. Slopes are opposite reciprocals. Right now, I've got -1/3 as a slope for number 8. That means the opposite reciprocal is going to be +3. So I've got y equals 3x plus b. I'll go use my x and y. -8 equals 3 times 0 plus b. -8 equals b. Y equals 3x minus 8 would be the line perpendicular to that one. And then last but not least, your friend claims that if a line has a slope that's less than 1, then any line perpendicular to it must have a positive slope. The friend is not correct, because if you have a line less than 1, what if you have, so I'm going to give like what we call a counter example, you guys. She says it's true if we have a line counter example. My counter example is, what if I have a slope of a half? This is a half is less than 1, isn't it? So this number is less than 1, but what would be the perpendicular to it? M equals -2 would be the opposite reciprocal here. So is it true? If your slope is a negative number, for sure that's true. But the fact of the matter, between 0 and 1, if your slope is between 0 and 1, it's going to be one of those fractions. It's perpendicular line will have a negative slope. So it's true that if the numbers are negative, that you're going to have a positive slope for its opposite reciprocal, but you've got to consider that these fractions between 0 and 1 aren't negative numbers to start out with, so their observation wasn't right.